Hello, I welcome you all to this another interesting screencast. The problem reads: at a given instant, a football player at A throws a football C with a velocity of 20 meters per second in the direction shown. Determine the constant speed at which the player at B must run so that he can catch the football at the same elevation at which it was thrown. Also calculate the relative velocity and the relative acceleration of the football with respect to B at the instant the catch is made. Player B is 15 meters away from A when A starts to throw the football. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So first things first, I will need to calculate the time. I think the time is important for me. Calculate the time it takes for the ball to reach this same elevation at which it was thrown. So with this time, I'll be able to use it to calculate the constant velocity of a player B. Okay. Alright, so let's draw. So let's imagine the ball is going to come up to there like so. Okay. And then let me just connect these points and connect these points like so. Right, something like so. Okay, there we go. There we go. Alright, there we go. Right. Okay. Alright, so we have this point here, and we expect the velocity here at this point to have the same magnitude at the same elevation. We're going to have components in this direction like so, and another one like so. Right, agree? And this angle here is just going to be equal to 60 degrees. Right, this magnitude here is 20 meters per second. This one is going to be 20 cos 60, which is just equal to 10 because cos 60 is 0.5, and this is 20 sine 60. Okay, 20 sine 60. Right, what else do we have? I will have some components there. They are like so. Alright, so this is just 20 cos 60. Okay, this is 20 sine 60. This one is equal to 10. Right, so let me call this point here. Let me call this point so I'll be interested in this. I want to find the time it takes from this point to this point. Okay, right, so let me call this point here. I call this point D. Okay, I call point D. Okay, this point, of course, I'm calling it A, and then this one here is my reference. All right, okay, so let's go ahead and find the time. So using the vertical motion. Okay, why vertical motion? Because I have a lot of knowns already. I know the elevation is the same. My reference final elevation will be equal to final elevation is 0 and the initial elevation is 0. S is equal to S naught plus V naught T plus half AC T squared. So S in our case is 0, S naught is 0, AC is 9.81 meters per second, which is a minus. This is a minus. What else? V naught in our case there, it is a 20 sine 60. Okay. Alright, so this is our Vy here. This one here, it is our Vy, V naught Y, and this one is our Vx, like so. Okay. So let's plug in these things. So we'll have a 0 equal to 20 sine 60. Our T here is TAD. Okay. So our T is equal to TAD. So by times TAD minus half 9.81 TAD squared. Factoring out TAD, okay, so this just becomes 20 sine 60, okay, so 0 equal to TAD 20 sine 60, and then minus this half there, half of 9.8 is what? 9.81 divided by 2. This is 4.905 TAD, like so. Therefore, TAD is just going to be equal to 0 in first case, and then the other one, TAD, is just equal to, that's 20 sine 60 divided by 4.095. So this is just equal to 3.53 seconds. So now let's find, we found the time from T to D. Let me call this, this one is our VD, which is equal to 20. Okay. All right. So we need to now find, let's call this XAD. We need to find XAD so that we find VB. So let's use the horizontal equations of motion. All right. There we go. So what do we have? We have S equal to S naught plus V naught T plus half AT squared. So our S in our case here is equal to XAD, okay, and then we have S naught equal to 15. We have V naught equal to V naught. We are trying to find VB here. We know the time it takes for the ball to get there, okay. So this is just going to be equal to VB, and it is constant, right? This is constant. What else? We have T, which is equal to TAD, and is equal to 3.53, and we have AC equal to 0. All right, so XAD, let's start with XAD. So for XAD, let's use this equation. XAD is just going to be equal to S naught, which is X naught, which is, so XAD, X naught For x at the x naught will be 0. Okay. For x at the x naught will be 0. And then we have v naught, which is 10 times the time, which is 3.5, right? Agree to this. This is our x naught, right? Okay, that part is 0. So with this information, we can say 10 times 3.53 is equal to 15, which is our s naught, plus vb times t ad. Okay, where tad is equal to 3.53, and therefore our vb is just going to be equal to that's 10 by 3.53 minus 15 divided by 3.53. So this gives us a 5.75. Okay, so this, in finding this, I just have to mention here our v naught for this was equal to 10. Our s naught was equal to 0, and our t was equal to 3.53, and then our AC was equal to 0. Okay, for finding this. All right, so we have our VB. So our VD, which is equal to our VD, writing it as a vector, is just equal to 10I minus 20 sine 60j. Okay, and then VB as a vector is just equal to 5.75 I. Okay, all right, there we go. So this is x and this is y. Okay, and then of course vd. So we are now being asked to find the relative velocity for relative velocity of the ball with respect to v at the instant the catch is made. Let me also write down the acceleration. Acceleration at d is just minus 9.81. This is just going to be experiencing acceleration due to gravity, and AB, which is acceleration for player B, is just going to be equal to 0. So with this information, we can write down the following. So our VB, our VD, okay, our VD, that's velocity, final velocity of the ball at the catch. Okay, this is final velocity at the catch. Okay, so our VD with respect to B, okay, just equal to VD with respect to B is just equal to VD minus VB. Okay, and this is just equal to this is equal to this is equal to 10I like this minus 5.75 I. Okay, so VD with respect to B is just equal to 10 minus 5.75. So this gives us a 4.25 I minus 20 sine 60, 17.5 32J. Okay, meters per second. So this we have found. So now let's find the magnitude. Let's find the magnitude. So our V D with respect to B magnitude with respect to B, which is just the magnitude. Okay, so this is just equal to square root of 4.25 squared plus 17.32 squared. Then VD with respect to B is therefore just equal to 4.25 squared plus 17.32 squared. Square root of that, we get a 17.83 meters per second. If we are to draw this, we have positive x, negative y. It's going to appear like that, and then the resultant is much closer to y because y component is bigger. So this one is b d with respect to b y, and this one is b d with respect to d with respect to bx. Then this one is just v v d with respect to b. Okay, and then we have the angle there like this. Right, and then the angle is just equal to tan inverse of minus 17.32 divided by 4.25. Okay, right, let me just move this a little bit like that. So theta therefore is just going to be equal to minus 17.32 divided by 4.25. Tan inverse of that, we have a minus 76.21 degrees. Minus because the angle is being measured clockwise with respect to the x-axis. So we can write this as theta is equal to 76.21 degrees, like so. Okay, so let's work out the acceleration. So AD with respect to B is just equal to AD, like so, minus AB. Okay, where AD is just equal to minus 9.81 J, and then AB is just equal to 0 because the velocity is constant. Therefore, AD with respect to B will just be equal to minus 9.81 J, okay, meters per second squared, or AD magnitude, the acceleration going down is just equal to 9.81 meters per second squared. Alright, I think this is about it. We have found the constant velocity for player B. We found the relative velocity of the ball with respect to the player B at the instant the catch was made. We found its magnitude, and we found its direction. Okay, there we go. And then acceleration, this is just in one direction. Only the ball is going to be experiencing acceleration in the vertical direction, and we have its magnitude there. Alright, I hope the video was helpful, and if it was, give me a thumbs up, like my video, consider subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.